Welcome everyone, and thanks for joining us for this Next in the Hub webinar series on patents. And many thanks to Tom and Katy from Abel and Imray who contacted us about doing this webinar, which is a really valuable addition to our programme. I will let Tom and Katy introduce themselves and hand straight over to Tom, who is going to talk to you about this. There will be time for questions at the end. If you hold on to your questions and type them into Q&A at the end, please feel free to introduce yourselves on the chat and we will keep an eye on that. And if you've got any issues, please let us know. With that, I'll hand over to Tom.
Great, thank you, Josie, and thank you for letting us come and speak to your group today. We're really pleased to be here. Hopefully everyone can see the slides all right. Today we're going to be doing a bit of an introduction to patents. We're going to think about what are patents, when should we be thinking about them, and how do you go about getting your innovation patented. So a quick overview then on our talk. We'll start off with a bit of an introduction to myself and Katy before we go through some basics on patents, and then we're going to use a catalysis-based case study on how you might identify a patentable invention. That'll lead us into when you want to be thinking about patenting, and then after that stage, asserting patent rights, and a little bit on freedom to operate. So that's thinking about other people's patents. And the last bit Katy's going to finish off with is how to get information from a patent. So that's more thinking about using them as a resource for your work in research. And then we'll have a summary and some time for questions at the end as well. So first of all, a bit about us. So Katy and I work with Abel and Imray. We're a firm of patent and trademark attorneys. So alongside our work in protecting technical inventions, our colleagues work with sort of protection of brands in the trademarks area. We have offices in London, Cardiff, and in Bath. And in our day-to-day work, we represent our clients at the UK Intellectual Property Office. So that's patents, designs, and trademarks in the UK. The European Patent Office, and also at the European Union Intellectual Property Office. The last one is for trademarks and designs in the EU. For getting protection for our clients outside of the UK and Europe, we have a sort of network of overseas attorneys we work with, local patent attorneys in China, the US, Japan, Australia, who can help get protection in those countries. And for the most part, our work is in drafting and filing, and we use the word prosecuting. In our world, that means getting a patent application granted. So you have that initial step of filing your application and then some negotiations to actually get it granted. That's what we do day to day. And alongside that, we do a fair amount of advice. So that might be advising on infringement by others of our clients' rights, or where our clients are concerned they might be infringing on someone else's. And the counterpart to that is whether or not those intellectual property rights are valid. So then this is me. I am a European and a UK patent attorney, and fortunately a European patent attorney is not an EU thing. I'll continue to be a European patent attorney after the end of next month. I work in our Cardiff office. I'm a partner in the Cardiff office of Abel and Imray. I was based in Bath until a few years ago, but moved across to Wales more recently. Before becoming a patent attorney, and you need to have a technical background to be a patent attorney, I had a master's from the University of Durham, and then after that did a PhD in Bristol. And this being a talk to a Catalysis group, I can actually give the title of my thesis. So I was working on bifunctional unsymmetrical ditopic ligands for alkene methoxycarbonylation. Since that work and becoming a patent attorney, I have a slightly broader interest technical area. I do quite a bit in the industrial chemistry area. That tends to be the focus of my work more than pharmaceuticals. So that might be petrochemical refinery work, polymer formulation and polymerization. I do a bit of catalysis still, quite a bit of heterogeneous, but also some homogeneous catalysis. And outside of that heavy chemistry stuff, I work with some clients are in the food area. So that's making food products, food manufacturing, packaging. And I have one client that builds and operates data centers, so big warehouses full of computers. So it's a fairly broad range of interests, which is time for me to get Katy to introduce herself now.
Thanks, Tom. So I am a trainee patent attorney and I'm based in our Bath office. So I started working and training at Abel Imray in early 2018. It takes quite a long time to train as a patent attorney to become both UK and European qualified. So I'm quite far through that process, but still got a little way to go. Like Tom, I have a background in chemistry. So I did my MChem at Cardiff University, and then I moved to the University of Bristol. I worked under the supervision of Duncan Wass in the area of biofuel. So I was converting bioethanol to butanol, and that involved homogeneous catalysis, so plenty of synthesis and then using my catalysts in that process. So being a chemist, my patent work includes lots of chemistry. So like Tom, I do work in the areas of heterogeneous and homogeneous catalysis, and lots of work in petrochemical refinery processes and polymers. I also do a fair bit of work in the pharmaceutical sector. And also, like Tom, I do some work which is more in the engineering fields, such as data center design and operations.
Great, thank you, Katie. So that's us. What are patents? Patents are they're a legal intellectual property right that is granted by governments. That means they're territorial. They're specific to the region, or more often country, that grants them. And the right that is given there is time limited. Pretty much everywhere now, that's 20 years from the date the patent application was filed. So from that filing date, the clock starts ticking, and once 20 years has run out, the patent is finished. It's all over. They're there to provide protection focused on technical function of an invention. So it's thinking about how something works, not really concerned with how it looks, but exactly what is the function it's providing. And the right is that you are given as an owner of a patent is to stop other people from using that invention. So it's not a right to use the invention yourself, it's to exclude others from using what you've developed. The deal that's at the heart of this is that inventors get this right to prevent others from using their invention in exchange for explaining how it works. So the idea is that inventors are encouraged to actually disclose their technology, how it works, because once that 20-year time period has run out, everyone else is free to use that invention. They can't be stopped from using it. So by encouraging inventors to share the technology, that's meant to drive innovation in the longer term. I should say as well that patents are a monopoly right. That means that the first person to file the patent application is the person that gets protection. Even if someone else totally independently came up with the same idea, if they came up with that later, then they're going to need permission from that patent owner to use that invention until the patent runs out, of course. So why might you file a patent application in the first place? Well, we said that what they're there really is they're providing inventors with protection for the technology that they've developed. So that's your first and foremost reason. But it can be a bit more complicated than that. You might be using them as a way of attracting investors if you're in a sort of early stage company. If people are going to put money into a company, they're going to want to see that a competitor isn't going to swoop in and steal the technology and just be able to exploit it after all that investment has gone in already. So investors like to see some protection of IP rights. Some companies use patents to highlight their status as being innovative, and you do see that in advertising sometimes. X number of patents protect this device, that kind of thing. And so it can be used as a marker for the kind of image that a company wants. They can be a deterrent. So even if you never end up taking action against somebody else to assert your patent rights, just having it may, at the very least, slow competitors down, even if it doesn't stop them altogether. And that deterrent can be quite valuable, even if it gives you a steal on the market. And as part of that, products can be marked as patented or patent pending, and that can help highlight that you have rights to what's in there. They can be used as a way of defining what belongs to different companies. So one thing that is relatively common is for companies that are going to work together in a joint venture to get patent applications filed for the things that they've invented before that starts, because there's no doubt then of who contributed what at the very beginning if someone's got their own patent application on file before information was shared. And finally, that point about bargaining power there is really thinking about the interaction between a company and its competitors. It's quite often the case that there are multiple organizations working in the same field with some overlap of technology. As I said, if you get your patent application in first, you get the rights, and someone that comes later doesn't. Well, it may be that there's a bit of an overlap there. Someone has developed a particularly advantageous aspect of technology and someone else has a different aspect of it. And you have perhaps a better position to get access to that earlier patented technology if you've got something to offer in exchange. So that bargaining power is, I've got some patents, you've got some patents, I'm sure we can work something out. And now I'm going to hand over to Katy, and she's going to talk a little bit more about what makes an invention patentable.
So there's 3 main requirements that you must meet in order to patent an invention. So this is that your patent has to be novel. Your invention has to be novel, it has to be inventive, and you must sufficiently disclose your invention in your patent. So starting with novelty, this means that your invention must be different over anything already known. So it's a relatively low bar. You're just looking for any kind of difference over what's come before your invention. And novelty is assessed against what we call the prior art. So the prior art is any earlier public disclosure anywhere in the world. So when you file a patent application, you get a date of filing, and your invention is assessed against anything that was disclosed publicly before that date of filing. So you must be novel over that prior art. Your invention also needs to be inventive over the prior art. So this is where the invention is not an obvious modification or a combination of the prior art. So we're not talking about an inventive leap. This is an inventive step. It's a more difficult legal concept than novelty, but a really good indicator to determine if you are going to meet the inventive requirement is if you have some kind of advantage from your invention. So you might be producing something, you might have a method of producing something better yield or higher selectivity. Any kind of advantage, in any way you're solving a technical problem, that's a really good indicator that you will meet the inventive requirement. And then finally, you must sufficiently disclose your invention. So this means that the skilled person, so that's someone who's working in a similar area to that your invention relates, must be able to work the invention based on the information that you've provided in your patent application. So we put lots of data and examples into patent applications to make sure that we're meeting this requirement. And typically you'd have disclosures in there about how you make your invention and how you use it. And the reason why we have the requirement for sufficiency is, as Tom touched on earlier, the patent system works on this trade-off between the proprietor being granted a monopoly for 20 years, and in exchange you disclose how your invention works so the public can learn from that, and hopefully it'll help innovate more technology. So what can you actually protect with a patent? Well, there's a broad range of things that you can protect, but generally we divide this into 2 different groups. That's products and processes. So products are things, so it could be a molecule having a particular structure or a composition. It can be devices or an apparatus. And then processes are ways of doing things. So it could be a method of making something. it could be a method of operating something, and it could also be using a certain product for a particular process. So there's a really broad range of things that you can protect. So I'm going to hand over to Tom now, who is going to go through a case study which hopefully illustrates some of these principles we've just discussed.
Great, thanks, Katie. So hopefully this will make it a little bit more interesting now. We're going to apply some of that explanation to a case study, which is based on a genuine situation. It's something quite close to my PhD studies. You probably won't need too much explanation of this graph. This is just a general idea of catalysis. You have a reaction between X and Y to make Z. The normal reaction route might require a certain amount of energy, and your catalysis gives you an alternative pathway with less energy. So that's what we're talking about in catalysis here. So a bit of background then for this case study. So this is what's gone before. This is what Katie referred to as the prior art in this example. So this company, and this is our company we're working for in this example, Chemcore, discovered a new and efficient route to making methyl methacrylate, that's MMA. MMA is a monomer used to make acrylic polymers, so it's pretty sought after, made on a pretty large scale. And the traditional routes for making MMA are sort of early 20th century chemistry, pretty wasteful. And the route that is normally used produces a large amount of byproduct. In fact, it makes more byproduct than product, and it's contaminated with cyanide. So it's not a particularly nice thing. But Chemcore have come up with this alternative route, and so they've taken a completely new approach here. And it's a two-stage process. First, we have a methoxycarbonylation reaction to make methyl propionate in the presence of a catalyst, a strong acid there as well. And the second step, they convert that on with the reaction with formaldehyde to make MMA. But it's that first bit we're actually interested in here. And just as a bit of an illustration, just in case there are any non-chemists watching this as well, what's happening in this first reaction is we've got carbon monoxide, so that little rod-shaped grey and red molecule on the top left, little linear molecule. That's reacting with ethylene down at the bottom left, and also methanol. That's the one with the grey blob and the red blob and some white ones around it as well. And all of those atoms are ending up in our methyl propionate on the right-hand side. So it's a very efficient reaction. Everything that goes in ends up in the product. So how does this work? What have Chemcore really discovered here? What they've found is a catalyst based on palladium and this diphosphine ligand that's called L1 here. And this is crucial to the process that's been developed. So we've got this diphosphine. It's got this sort of linker between the two phosphorus centers, the two Ps. And it's got these tertiary butyl, big spiky, bulky groups on each phosphorus. And when that is combined with palladium, which is what's shown on the right-hand side, we get these two phosphines taking up 2 of the sites. There are 4 there available. And it's in positions 1 and 2 that all the good stuff happens there, really. That's our free sites where catalysis can happen. So I said on the first slide that catalysts can provide an alternative route for a reaction. So we think back to we were reacting X and Y to make Z. Well, those 2 sites, 1 and 2, are the spaces in which reactants can come in, join onto the metal center and react together. So that's what the sort of catalyst looks like. So as I said, they've got this process of making methyl propionate that works very effectively. But what's the discovery we're looking at here? So that's all of our background. Let's have a think about what our research is. So our ongoing research was, maybe we could expand this to some different catalysts. Is it just this new one, this L1 ligand that works, or can we think of some others? So the first one we might try is a variation on that first ligand. We're going to call this one L2 instead. And now, rather than using those big bulky tertiary butyl groups on each phosphorus center, we're now using phenols instead. You probably got a picture of that in your mind, but these are sort of more like dinner plate shaped things, so they're less bulky, still fairly big, but because they're relatively flat, they don't take up as much space. And it turns out if you use this L2 based catalyst instead, you don't make your methyl propionate, you end up making a polymer. It's actually a polyketone, so you've got just a big sticky mess and not what you wanted. So that didn't work very well. But of course, undeterred, you thought you'd try something else. Be interesting to see what would the hybrid combination of these two things give. So we know that L1 give us our methyl propionate. We know that L2 makes a polymer. What about the hybrid of those? So we've got the big bulky 2-butyls on one side, the phenols on the other. And it turns out that we do make methyl propionate after all. And not only do we make methyl propionate, which is exactly what we're after, we make it with even higher purity. So not only have we discovered that we can use a different catalyst that might be useful in itself, but we can make our product in higher purity. So we're now in the realm of having discovered something new, we think, which has an advantage. How does this fit into patenting then? So we think we've come up with something. Now it's time to do a little bit of analysis on whether we have an invention here that's patentable. So as Katy said, requirements for patentability. Firstly, is it new? Nice black and white question. Was it known before? Secondly, has we solved a technical problem? That comes down to whether we're inventive or not. So now it's time for a bit of literature searching, really, if we haven't done that already, to really think about what we've come up with. So you first of all, you might think about this ligand L3, this hybrid thing here, unsymmetrical diphosphine. Is that in itself new? Well, that's a literature search. Is it already out there? If it is new, have we solved a technical problem? Well, yes, when we use it in catalysis, we make a product with higher purity. So that seems pretty promising. But maybe that L3 ligand is known. Perhaps that was already out there. So then we can sort of move down to a slightly narrower scope. How about a catalyst comprising that L3? Has it been used in catalysis before or used in something else? Is it accidentally disclosed somewhere else? And again, literature searching, are we new or not? If we're new, yes, we solved a technical problem, we're making a highly pure product. But maybe it has been used in a catalyst before. If it has been used as a catalyst, then our last roll of dice there, I suppose, is has it been used for make MEP? So have we been used in methoxycarbonylation before? Yes or no? Well, if it had been used before, then this whole project's been a bit of a waste of time. So let's assume that is unknown. And again, same technical problem we solved, making our product in high purity. So something in here is going to be new, and it looks like something is inventive. But we probably want to step back now a little bit to think about what does a patent application start to look like now? How are we going to protect this? We don't particularly want to have something that is so narrowly focused that it is only on this specific catalyst with this exact structure, because you can imagine that there are various aspects of that structure which perhaps aren't essential. Maybe the backbone could be tolerant of having other substituents on it. Maybe it could be a different shape or length of backbone. Is it just phenol and 2-butyls we can tolerate? Can we have other big bulky groups on one phosphorus and smaller groups on the other phosphorus? So now we're starting to think about what's really essential. And this is where we can really scope out the invention. What have we actually invented here? So in thinking about what's essential, you might want to think about what alternatives might also work. And then if you can think of alternatives that might work, do we have enough information? Katy said earlier on that sufficiency is an important part of this, this approach. We need to disclose enough in our patent application that makes it plausible that everything we're trying to claim as ours, we have actually invented. Just coming up with one catalyst and then using that to support, well, now we can claim a whole class of catalysts, isn't particularly plausible. Do they really all work? Have we demonstrated that they all work? Have we at least demonstrated some of them? So the answer is probably no, we don't have enough information. And then the question is, well, where do we go when we're trying to support a patent application now? If we want to get a patent application that protects what's really essential, we're going to need to better understand our invention. So we go back to the science, the chemistry at this point, and think about how does this invention actually work? We want to understand why it is that our hybrid, which is L3, so the combination of the phenol and 2-butyl, Why does that work while also the T-butyl symmetrical one works, whereas the other doesn't? We've got one that made polymer, if you remember, where we have phenols on both phosphoruses. So we need to have a bit of an explanation for that if we're going to support a decent scope of protection. So that means looking at the catalyst and looking at how this works, and some investigations can help us with this. So we take our catalyst structure and start to probe it, do some studies if we can work out the mechanism. And in this case, the mechanism is that the first thing that happens in the catalysis is the ethylene comes in and joins on to a palladium hydride here. And then once they're in together, we get a bit of a rearrangement. So the hydrogen and the C2 unit have combined together. And that's opened up a space where carbon monoxide comes in. We can, test this out with various different studies. Once the carbon monoxide has come in, we start to grow our product. So we've combined the carbon monoxide and the ethylene, and we've got a vacant site sat there waiting. And this is the point that really determines whether we get what we want, which is methyl propionate, or we get polymer instead. And there are two things out there in our reaction mixture which could come in at this stage. We could have some more ethylene, and if another ethylene comes in, then we start growing our polymer because we start getting alternating CO and C2 groups, and that makes our polyketone. But the alternative is the methanol. The methanol is out there as well, and maybe the methanol could come in. And that is the answer here, that if methanol comes in, then MEP drops off and the whole reaction starts again. And it turns out that what's important is to have the T-butyl, those big steric groups, just on one side. You need them on one side because they've got to be sat there hindering this site. And the reason this works is that although ethene and methanol are similarly sized molecules, ethene has to come in sideways to form that bond with palladium, whereas the methanol comes in sort of head first, really, oxygen first, and it doesn't need as much space to get in. And so the T-butyl groups there, as long as they're sat down there next to the vacant site, those big bulky groups prevent ethylene coming in, methanol comes in, and we get our product. So now we have a much better idea of how our reaction works. And that's why we can get away with bulky groups on one side and not the other side, and it does still work. So back to our thoughts then of what does this mean for scoping out the invention? Well, what is essential? We've got to have big bulky groups on one side. That's essential. What alternatives might also work? Well, now we found this out, our alternatives that might work. All sorts of things could be put in instead of the phenol group. We've got this idea, it's all about bulkiness. Maybe there's other substituents on that phosphorus other than T-butyl. We could try a couple of those. We haven't really thought about the backbone here. I think the backbone is like to be relevant because we've got to be holding those T-butyl sort of, so they're sticking out in the right direction to block that site. So you could imagine that a more flexible backbone might be less helpful. So you might want to test a couple of ideas there as well. But you can see how this turns into a bit of a research project now, and how we can supplement what we had with information to justify a decent scope of patent application. And once it hangs together and you have a sort of plausible story for what you've invented and what's essential, you can then really get some decent claim scope there. You don't have to show absolutely everything. You don't have to test every single different catalyst that could fall in the scope of the claims, but you need a range of them to have a theory behind why it works and what doesn't work. So that brings us to the question of when do you think about patenting, or when do you think about filing a patent application in particular? And as I think our study is perhaps shown there, that we have a bit of a balancing act here. You don't want to do it too early. You need to have properly supported what you've invented and your discovery so that you really understand how it works or how you think it works. And that can give you the basis to claim something a bit broader than just the specific thing you've come up with, because you don't want to leave your competitors room to come in and make a sort of fairly routine inconsequential change to what you've invented and be outside of your patent. And you can only really get that broad protection by being able to properly support what you've come up with. We don't want to leave it too late. you need to stay ahead of your competitors. You might not be the only people working in this area. And if they get their patent application on file first, then you're going to be too late. And of course, you want to be doing this before you disclose any of this yourself. It's very, very important that patent applications are filed before anything is put out in the public domain. So that means before talking about it to other research groups, unless you have some kind of collaboration agreement that makes it all confidential, certainly before going to a conference and talking about it or publishing any papers. That's really important. Once you've done that, you've pretty much lost your ability to patent almost everywhere. Right, so that's my bit of case study on thinking about scoping out an invention. I'm going to let Katy go into more of the detail of how you file a patent application.
So this slide shows a general strategy about how you can go about getting patent protection. It's not the only way you can do it, but it works generally well for people based in the UK. So first of all, you would draft a patent application, and then that is filed at the UK Patent Office. So you then get your important date of filing. The UK Patent Office will then carry out a search for relevant prior art, and they will issue a search report. So this is useful because it gives you an indication about whether your invention is novel and inventive over the prior art, and how easy it is to obtain patent protection, and it gives you an indicator of the kind of scope of protection that you might be able to get. Then at 12 months from filing your UK application, you need to decide whether you want protection in other countries. So the reason you have this 12-month window is provided that you file patent applications abroad within the 12 months, then those foreign applications will get the date of filing of your first UK application. So this is important, again, for the reason of prior art. You want your earliest filing date of your UK application, because if there's been any disclosures between the first filing of the UK application and then any foreign applications, then that doesn't count as prior art. So that could include your own disclosures or third-party disclosures. So if you want to obtain protection in a few different territories abroad, then it's best to file what we call an international application. So an international application is best thought of as a bundle of options. So it's not actually going to turn into a patent itself. There's no such thing as an international patent. But what it is, like I said, it is keeping the door open. So at a later stage, you can then turn it into a series of national applications. So once you filed your international application, a patent office will then conduct another search. So for people based in the UK and Europe, that will be the European Patent Office. Then you're getting more information about what prior art's out there, and you can make an informed decision about the scope of protection you're likely to get. Then your next big decision comes at the 2.5-year mark from filing the first UK application. At this point, the international application turns into a number of national or regional applications, so you need to decide which countries you're interested in. These applications are then treated independently of one another, so they will be examined by the various different patent offices, and you go into an examination process, which is a negotiation between yourselves and the patent office over a few years to come up with scope of protection that both you and the patent office are happy with. There's something else called a divisional application. So I'm only going to mention that very briefly. A divisional application is when you split an application into multiple separate applications, which cover different aspects of an invention. So an invention might itself encompass a number of smaller inventions, if you like. So you can have a whole patent family that covers those different aspects. And also, it's really important to remember that you must pay renewal fees. So when you are coming to a decision about when to which countries you want to obtain protection in, it's really important to factor in that renewal fees need to be paid. So I'm now going to change topic slightly to discuss enforcement. So what can you actually do once you've got a patent granted? Well, the first thing you could do is not very much. You can pay your renewal fees to make sure that your patent remains in force, but you might find that having that patent alone is enough to deter any competitors from operating in your market and using your invention. Or you can enforce your patent. So it's important to note that a patent can't be enforced until it's granted, but it can be enforced against a third party that is infringing the patent. So Tom mentioned earlier that patents are monopoly rights, so it means you don't actually need to show copying. So a third party, even if they come up with the invention and use it independently, they haven't copied it from you, you can still enforce a patent against them. There's different types of acts which are deemed to be infringements of a patent, depending on what you've protected. So for products, it's an infringement to make, sell, use, import, or keep that product. And for processes, it's an infringement to knowingly use or offer for use that process. And there's also protection for the direct product of a process. There's also something called contributory infringement. So it might be that a third party isn't providing the whole invention, but if they are knowingly supplying an essential element of the invention, so that's something that's needed to make the invention work, then this could be contributory infringement. There are some exceptions to patent infringement. So the most important two are private and non-commercial use. So if you're using something that's patented in your own home, you're not doing it commercially, that's okay. And also there's an exception for experimental purposes. So the flip side of enforcement, if you enforcing your patent, is that the third party does have a number of defences that they can use if an infringement action is brought against them. Firstly, they could be found to not infringe the patent. So when an infringement case goes to court, the court will pick over the wording of the patent in a lot of detail, and they will determine exactly what that patent covers. So they might find that actually the third party, what they're doing is not covered by the patent, and therefore it's not an infringement. The third party could also claim that your patent is invalid. So the third party will extremely likely carry out their own search. So patent offices are generally very good at searching, but they tend to focus on patent documents, and the prior art covers any disclosure. So if that's journal articles, presentations at conferences, anything at all that's available to the public. So they're quite likely to find something that is relevant to your invention, and it might be found that your invention lacks novelty or isn't inventive. A third party is also likely to claim that your your invention is insufficiently disclosed, so they can't actually work the invention. So this is a good reason, another good reason why you should include plenty of information in your patent application about how your invention works. There's also something called prior user rights. So this is quite a rare situation. This is when a third party have secretly been using the invention before the patent was filed. So provided they've been doing that in secret, they may be able to continue what they were doing before the patent was filed afterwards. The reason this needs to be done in secret is if that third party were using the invention publicly, it was known, then that itself would be prior art and you wouldn't be able to get a valid patent. So I'm going to go back to Tom now, who's going to briefly discuss freedom to operate.
Thanks, Katie. So we've been talking so far about how you would patent your your own technology, and then what you might do with your patents. If you are working for a company seeking to commercialize something, the other side of this to be aware of and keep in mind is freedom to operate. So I said right at the start that if you're granted a patent, that's not granting you the right to use your invention, it's granting you the right to stop someone else from using your invention. And those aren't quite the same thing. The way you can imagine this is to think about areas of technology where multiple different people are developing improvements all at the same time. And the very basic one to imagine is, say someone invents a bicycle, they get a patent for the bicycle, you think you can improve it by adding a brake, so you invent a brake for a bicycle. That's all well and good, but you can't go selling bikes with brakes on them without getting permission from the person that owns the patent for the bicycle. And when we said earlier on about the sort of bargaining value of patents, it may be that the person that makes bikes would quite like to also sell them with brakes, and there could be some kind of cross-licensing thing there. But all this means that the freedom to operate is a bit more complex than just working out if you've made something that's new and inventive. So freedom to operate searching is quite important as part of the commercial development of a new product, and as a general rule it's carried out during that development, certainly before its launch or its use. Timing can be a bit tricky with that one as well, because you want to make sure that you do that early enough that you're not so committed to a particular way of making or structuring your invention that you couldn't change if you found insurmountable third-party rights that are out there. But if you do it too early, you might not have finalized exactly what you want to do. And so that freedom to operate exercise could be a bit of a waste of time. So it's a bit of a balancing act. And in practice, a way to do that is to do a bit of freedom to operate searching as you go along and refine it as you arrive on something closer to a final product. The next point I said there is patentability searches not being a substitute for freedom to operate. Again, it comes down to this point: you could have something which is new and inventive, but still not have the right. You still could be blocked by someone else's patent rights from using it. And when patent offices or searchers are looking at novelty and inventiveness, they're not really thinking about freedom to operate, and the search isn't going to be framed in quite the same way. Using our trivial example again, a patent office thinking about whether your brake for the bicycle is new and inventive, probably be thinking about other disclosures of brakes and means of stopping things. They might not really be that focused on the bike itself, and so you may not find out about the patent for the bike just by looking at the patentability search results. So they are something to be taken on separately. Reasons for doing this: defending an infringement action, if you find yourself in that situation, can be very expensive, and it's certainly very distracting for the business. And at the worst end of the spectrum, these aren't particularly common, but they do happen. Something called a preliminary injunction, which is where one party gets wind of someone else about to launch a product and gets sort of an emergency injunction put against that to stop that coming to market. If that's done at a very late stage, that can be hugely costly and damaging to reputation. So you don't want to be in that position. Freedom to operate searches rarely come out with a black and white, everything's okay, or this is a disaster, you just can't go anywhere near it. Those don't tend to be the answers. It tends to be in the more grey area of there are these other rights out there. There's a bit of an issue there, but it might be okay, it might not. What they're there for in that situation is allowing the business to quantify what risk it's willing to take. Does it want to make sure it has an alternative way of making a product? Does it want to make sure that it has got a market in countries which are not protected by patents? I said back at the start that patents are a geographical. They tend to be national or in some cases regional. Even a European patent may actually only be valid in a small number of European states, because as Katy said earlier, you need to pay renewal fees on things, and not everyone pays the fees in every country. So it's kind of allowing the business to think about that. Is it still worthwhile sorting out this product? What steps they want to take to protect themselves? I'm not going to go any further detail of freedom to operate this time, but you could apply it to the case study we were looking at earlier. You could easily imagine competitors having also developed things, developed similar catalysts, and there being some overlap. So that sort of fit back more into your area. But instead of that, we're going to finish up now with some comments on sort of extracting useful information from patents. So Katy's going to talk a bit about searching and how you might use patents as a resource as part of your research.
So this will be our final topic that we'll discuss. So I'll just take a few minutes. So I wanted to talk about patent searching, and in particular how you actually read a patent, because when I was a researcher, I found patents very confusing. Most often I would see them cited in research papers, and I'd want to have a look at them, but really struggle to get much information from them at all. So I've put here searching by patent number. So a patent number is probably the easiest way to find a patent. So in a research paper, you'll find the patent number cited. And just to break it down, what this number means, the first two letters relate to the country code. So I've written down on the bottom left probably the most common countries that you'll come across. Then you have a year of publication, a serial number that's unique to the patent or patent application, and then the final letter indicates whether you are looking at a patent application, which would be an A, or a granted patent, which would have the letter B. So as I said, you can search by patent number, and on this slide, I've got a few different useful patent databases. So probably the most useful is a SPASnet. This is run by the European Patent Office, but it doesn't just include European patents. There's patents from all over the world. So you can search by patent number, by name. You can look for patent families. So it might be that you've come across a patent that looks interesting, that's a US patent, and you want to see if there's a UK or European equivalent. You can also search by keywords, and there's also a classification system. So this is when the patent offices give patents different codes, which groups together similar kind of subject matter. There's also patent scope. It's quite similar to a SPASnet, but an advantage of patent scope is there is a chemical structure searching tool. And finally, Google Patents is available. It works in much the same way as normal Google. You can just type in some keyword searches. I think if you're very new to looking for patents, I'd recommend having a go at Google Patents first. And then if you find a particular patent that looks interesting, then going to a SPASnet or Patent Scope and taking a more detailed look. So our final slide of the bulk of the talk is how you go about reading a patent. So I want to explain this from the point of view of a researcher, not a patent attorney. So a patent is quite a long and complicated document, but there are some sections which are consistent across all patents. So you have the introduction. I would recommend reading the introduction. It's usually only a couple of pages, 3 at most, and it describes the general problem that the invention relates to. It might discuss very briefly inventions that have come before, so the prior art, but it's really good for just orientating yourself about what is this invention to do with. Then you have the general description. This is the bulk of the patent quite often, and you'll see there's lots of repetitive language. Really, the general description is put in there by patent attorneys to help them prosecute the patent. There can be some useful bits which describe advantages of the invention, but really you're not going to extract too much useful information from the general description. The really key part for you to look at as a researcher is the examples and the figures. So the examples are written in a very similar way to the experimental section of a paper. It will show you specific ways of performing the invention. It should show you how you make whatever it is the invention relates to. So if it's a catalyst, it will give you the prep for making that catalyst. So I'd really recommend going and looking at the examples section. Finally, you have the claims. Really not important at all as a researcher if you're just trying to extract some information from the patent to help in your research. The claims are there to define what is protected by a patent. It doesn't give you more information than you would get from the examples. So that finishes off the bulk of our talks. I'm just going to let Tom summarise what we've talked about this afternoon.
Great, thanks, Katie. I'll just wrap this up quickly and then we'll have time for some questions. So as a bit of a reminder, patents are there as a deal between government and inventors. Inventors gets 20 years of exclusivity. Everyone else gets to be told how the invention works so they can use it once that runs out. If you are working on something new and you think you might want to commercialize it at any stage in the future, do speak to a patent attorney before you disclose it. We're friendly people and we've got technical backgrounds, so we can try to be pretty helpful there. Other points to think about: patents territorial. That means that you are going to need to get patents in each country that is of interest, not just one big international patent. And finally, if you are looking at commercialization, don't forget about your freedom to operate. Again, speak to an attorney to get a bit of steer on that. And I think that pretty much finishes us off. So if you have any questions, please do direct them over and Josie might be able to collate them together for us.
Yes, please. If you've got questions, if you could type them into the Q&A box at the bottom of your Zoom screen and I will read them out for Tom and Katie. Thanks, Tom and Katie, for a really informative talk. I certainly remember when I was doing my PhD, trying to search information from patents and trying to figure out what they were saying was challenging. So it was really useful to find out a bit more and to find out how we can use them or utilise them in our research. Okay, so we've got some questions coming in. So we've got a great talk, thank you very much. A broader question for you both. What attracted you to this career? What made you change from research into this area? And any advice for PhD students thinking about pursuing a career in this sector?
Well, Katie's a lot closer to that than I am, so I'll let her go
Yeah,
first.
I can start. So for me, what attracted me to the career was I really did like research, but I didn't really want to stay in the lab. I wanted to stay involved in chemistry, but yeah, to move out of the lab. And I think being a patent attorney really offers that. We work a lot with inventors and companies and we find out about all this interesting science that's going on, but I don't have to do the experiments and don't have to get upset when they don't work. So advice, if you're thinking about pursuing the career, do plenty of research to see what the job's like. There's a really useful website, which is IP Careers. So I spent a lot of time looking at that before interviews. You can always try and have a chat with a patent attorney. It's very, very difficult, I think, to get some sort of shadowing experience, but in general, if you want to send questions to maybe trainee patent attorneys, they'll be happy to answer. Yeah. Tom, anything to add?
No, I think that sums it up really. I find that it gives me a broader range of things to look at and learn about. It's not the same as research. You don't get the same detailed understanding thing. So it depends what you really want.
Thank you very much. So we've got a question from a medicinal chemist, Gagan. Sorry, about my pronunciation. Does including prophetic examples along with actual examples synthesized really help in claiming those prophetic examples, though generally those would be covered in claims?
Yeah, so that's a good question there on whether they're useful or not. They're not especially useful in terms of genuinely supporting the scope of the claims, because it's usually pretty clear that they are just prophetic and so they haven't actually been performed. So you're not going to have data there which shows that what you've come up with is inventive or how it definitely work. though where they can be more useful is giving you a bit of a hook to get data in later if you want to. So with a patent application, you have to have everything that you want to claim, or your sort of your general stuff in there on filing. You can't go adding new material to try and claim later, but you can file supplementary data to provide extra evidence of why your invention is inventive, and in particular why it's inventive right across the scope of what you're trying to claim. And so prophetic examples can be useful in that situation, because they can show that you think it's going to work in this way. It helps flesh out your theory as to why the invention works. So with the one we went through in the talk, it's sort of thinking about why it would work across a variety of different structures. You might imagine other things to try out, and if you've at least planted that idea that it could work across different compounds, different tests, then getting the data in later is a bit easier. So it does help from that point of view of being able to add things later, but it's a bit limited in what it does.
Okay. Hope that helps. Marina would like to know, she thought Tom had said that you can work in the sector with only a PhD.
Yes, so that's not, I possibly gave the wrong impression there. You need to have a technical degree, so you need to have basically a STEM degree and at least an undergraduate degree to be a patent attorney. You don't need to have a PhD. A PhD might help in some fields. It depends on the field. Some people have an idea that having a PhD might make it slightly easier to talk to inventors, particularly if you're doing a lot of research heavy work in your field, but it's certainly not a necessity. It's the undergraduate degree that is needed. And then in terms of training afterwards, patent attorneys train on the job. There are quite a few exams and there are some courses to go to, but that is all as part of a sort of training contract generally. And Katy is neck deep into all of the fun of the exams at the moment.
So I have one following on from that. So Katy, you said you started training in 2018, so it's been at least 2 years so far.
Yeah, it's coming up to 3. Yeah,
coming up to 3. So is it a 5-year training, or how long's a piece of string?
I would say, yeah, it's on average probably 4 to 5 years. Essentially, it depends on when you take the exams, which is generally your choice. So for the UK's, you have to sit UK patent exams, and you'll generally be taking your finals either 2-3 years. Kind of depends when you feel ready. For becoming European qualified, you need to do a set of exams for the European to become a European patent attorney. Those you can't do the final exams until you've actually had 3 years of experience. So you're kind of limited. That unfortunately not uncommon to fail exams first time. So probably want to factor in that. But yeah, in general, I think most people 4 to 5 years to fully qualify as both UK and European patent attorney.
Thank you. I think that's all the questions we've got live. Oh no, one coming in. Going with the PCT route is better than, or going with the conventional one? Which one works when? So this is a follow-up question from the medicinal chemist.
So Katy described the general profile of sort of getting patent protection, and the example that Katy gave was filing a first UK application and then following it up within a year with an international or PCT application. And that is a fairly typical route. It's fairly drawn out because you don't end up pursuing your patents in the particular countries you want until 2.5 to 3 years after your first filing. So there's quite a lot of sort of dead time in that. That's typically how it works. And it's quite costly in the sense that the fees when you start going into the PCT route are considerably higher than they are just at the UK Patent Office. They're thousands of pounds versus hundreds of pounds. That's not including the attorney fees, that's just the official fees. And then when you want to convert that into patents in each of the countries you're after, that can be expensive again. The answer of which is better is really a question of what countries you want to get protection in. If you're only interested in the UK or just the UK and Europe, and you definitely aren't interested in getting any protection outside of those countries, then either just a UK patent application on its own or a UK and a European patent application you can file in Europe without going through the international route, would be more cost effective, because you're not sort of taking your time and money up with the international route. But as soon as you start wanting, as you have an idea that you might want protection elsewhere, what the PCT is very, very good at giving you is time to decide what to do, because you don't have to commit on which countries you want to go for until 2.5 years in. Whereas if you take the route that doesn't follow the international approach, you have to decide on all those countries within 12 months. And that can be a difficult decision to make. So, and once you do start, if you are going into Europe, then in the longer term, overall, you don't spend an awful lot more money going via PCT, because a lot of the work is done by the European Patent Office. Just in handling a PCT application, it saves a bit later on. So it's a bit of a tricky balancing act, but if you're looking at protection overseas, generally the PCT is a bit better.
I think with one final question, which I think goes back to the qualifications. What's the best route to qualify in the US? Is that in the US or for the US, or both? I don't know if it matters.
So we're slightly out of my comfort area now. So so as a mention those two things slightly differently, I suppose. So Katy and I, well, I am a European and UK patent attorney. Katy will be before too much longer. We do prosecute patents for our clients in the US, or at least we seek patent protection in the US for our clients. We do that with the aid of a local attorney. So we do the initial bit and the international bit, and then we hand over the case to a US attorney who acts under our instructions. So they interpret the sort of US specific legal requirements. We provide them with our comments, and sometimes they adapt that to suit the particular way the US Patent Office like to see things. Each country tends to have its own approach to inventive step. We said that's a bit of a grey area, and there are different sort of tools for tackling that in the different countries. So we use a US attorney to provide that expertise. So there is no difference in terms of being able to help clients get US patent protection. To become a US patent attorney is a totally different set of qualifications. The US patent exams is a similar kind of thing, in the sense that you have to do all these different exams to become an attorney, and I think that is typically done as part of a training contract. I'm not all that familiar with it. We don't have any US qualified attorneys in our firm, and like I'm fairly sure this is the case for almost everywhere. You need to be sort of active and resident in the country to keep that going, really. If you're not based in the US, then you won't be a practicing US attorney.
Okay, Princess, that's brilliant, thank you. I think that's the end of the questions we've got in, and my Zoom is just telling me my connection is unstable. So I will finish by thanking Tom and Katy again. That was amazing, really, really useful information. I've already had several people asking me for the recording. So thanks very much, and thanks to everyone who came and listened. As I say, we will put the recording up on our website if anybody needs a refresher or a reminder. But thanks again to Tom and Katy.
Brilliant.
Very welcome.
Thank you
for
having us.
letting us come along. We've enjoyed it.
Thank you.